My name's James Bezic. I'm a Senior Developer Advocate here at AWS Serverless. Today I'm going to show you the S3-to-Lambda Serverless design pattern and how it can become a flexible core for your serverless applications. In this model, you configure S3 to notify Lambda when certain events happen. In this video, I'll show how this works in detail, review the characteristics of both services, and why knowing these is useful. I'll also discuss how this is a really useful tool for building highly scalable applications. S3-to-Lambda is a powerful combination when designing serverless solutions, and it can be important as a starting point in thinking about your system's design. When an object is created, copied, or deleted in S3, S3 can invoke Lambda. You configure notification settings on a bucket and grant S3 permission to invoke a function based upon resource-based permission policies. It invokes asynchronously with an event containing details about the object and can match on an object key, prefix, or suffix. And if you need to fan out, you can also link this to SNS instead. What are the characteristics of these services? Well, S3 is object-based and provides 11 nines of durability and has virtually limitless storage. It provides lifecycle management, so you can expire objects or move storage tiers based on rules. It supports encryption and provides a fine-grained permission model. Lambda is our functions as a service offering at the heart of the AWS Serverless portfolio. It provides 100 millisecond billing, so you're charged for the length of time you use the service. You can configure memory, which also controls the amount of virtual CPU available to your code. It also supports a number of runtimes, including Node.js, Python, .NET, Go, and Java, and you can bring your own runtime too. We have people using PHP, Perl, and even COBOL. It's stateless and scales automatically, and it's event-driven. The reason for highlighting these services' main capabilities and features is that it's important when you combine these services. You can get the benefits of both services in a single application. If you've worked with Lambda in any way or run through any tutorials already, you've probably come across this example. This solution allows you to optimize images stored in S3 at the point where they're written to the bucket. It uses a Lambda function to process the image to optimize the size and quality. What happens here is that an S3 bucket exists to receive the images. A Lambda function is configured to resize or optimize an image using a library like ImageMagick. The S3 bucket triggers the Lambda function, and after the image operation, the final image is stored in a second S3 bucket. There are many implementations of this available online for different runtimes using different image libraries. It's an often quoted example, so I won't rehash it here extensively, but it shows some of the important ideas behind serverless. So why not just resize images using EC2? You could easily install a script on EC2 to crawl images in buckets and process them in a similar fashion. Well, the image resizing example highlights some key benefits of taking this problem and approaching it serverlessly. First is scalability. We bring compute to the data. What do I mean by that? Well, it's less obvious when you observe the image resizer function operating on a single image, but if thousands of images arrive, you can see how Lambda responds and scales up. From the developer's perspective, you only write the code that would manipulate a single file and don't need to worry about how it works at scale. It shows how event-driven architectures work in a distributed system. Lambda is inactive until triggered by an event, in this case the arrival of a new object in an S3 bucket. This event invokes the Lambda function with a JSON payload describing what just happened. The Lambda function performs its work and then terminates. In terms of flow, the control is orchestrated by the event happening. Cost is another consideration. Not only are you paying per image resized, both in the storage in S3 and the invocation cost of Lambda, but this also makes cost more easily attributable. If you're building a SaaS product or an application for clients, it's extremely easy to calculate the cost by customer. For security, between the access control lists on the objects in the bucket policy, and the IAM policies of the function, if configured with the principles of least privilege, it can create a highly secure approach to the problem with minimal ongoing security maintenance. And finally, it's serverless, so that means there's no operating systems to patch, instances to scale, or infrastructure to manage. Now, although the image resizer function is definitely interesting and useful, It's only the beginning of the things you can do when you attach a function to an S3 event. This is also a good point to introduce Sam, the serverless application model. Sam's also a squirrel, who's the mascot for our service. As you start to develop serverless applications, you'll be creating infrastructure, Lambda functions, and triggers invoking Lambda functions. You can do all of this in the console, but it's much easier to automate through code. Sam is a CloudFormation extension designed to make the serverless application deployment that much easier. Sam simplifies the deployment and configuration so you can deploy the entire solution using simple commands from the CLI. Once you have a template, you simply type sam deploy on your command line. Here is a simple SAM template that you'll see in one of the future videos. This tells AWS CloudFormation that it's a SAM template that it needs to transform. It specifies an input parameter, in this case a bucket name. In the resources section, it creates an S3 bucket and also creates a Lambda function with the correct IAM policy specifying the language runtime and memory required and where the code can be found. It also specifies the event triggering the Lambda function. In this case, it says when new objects arrive in the bucket, it's looking for objects ending with .txt. Now, when you run sam deploy on this template, it actually creates the infrastructure. It would create the S3 bucket, the Lambda function, a DynamoDB table, and a second Lambda function. The S3-to-Lambda pattern is very powerful, but actually very simple. The services handle scaling automatically, so your custom business logic only needs to focus on the tasks that matter to your application users. Using the serverless application model, our friend Sam, it's trivial to set up in your serverless application using just a few lines of YAML. Since S3 buckets can contain a virtually limitless amount of data, and Lambda functions scale automatically when triggered by S3 events, this makes it easy to build enterprise-grade solutions with minimal code. In the next few videos, I'll walk through specific examples showing how you can use this pattern to provide useful functionality in your business applications. I'll show you how you can do things like automated language translation, workflow management, and bringing sentiment analysis to audio recordings. Thanks for joining me for this brief introduction. To learn more about Lambda, visit aws.amazon.com/Lambda. I hope to see you next time. Happy coding!